Hello and welcome to 3.3 lesson video. Today we're going to be learning about systems of inequalities and our goal is that we can solve them. So let's first talk about what a solution is of a system of inequalities. The solution of a system of inequalities is the set of all points that satisfy both inequalities. And this can be found on the graph in the intersection or the overlap of the corresponding half-plane solutions. So wherever you see the two graphs overlap, that is the solution of the system of inequalities. And how are we going to go about solving for this system of inequalities? We're going to graph, typically, because that usually works best. There's also another option that would be using a table. That works if the system has whole number solutions. We're not going to be discussing that in today's video, but you can feel free to take a look at it in example 1 on page 149. So like I said, when we're going to graph a system of inequalities, you want to make sure you're looking for the overlap of the shading. Sometimes the boundary line will be included in the solution set. In example 2, we have this system of inequalities. The first one is 2x minus y is greater than or equal to negative 3. And the second one is y is greater than or equal to negative 1/2 x plus 1. Before graphing, you want to make sure both of your inequalities are in slope-intercept form. The first one looks like it's not, but the second one is. So let's take the first inequality and solve for y. So the first thing we're going to do is subtract the 2x to the other side. So we have negative y is greater than or equal to negative 2x minus 3. And from there, we still have a negative 1 in front of that y, so we want to divide both sides by negative 1. Please remember that when you're dividing or multiplying by a negative number and you're dealing with an inequality, you need to account for that sign change by switching the inequality symbol. So now we have a less than or equal to, and that leaves us with y is less than or equal to 2x plus 3. So I'm going to go ahead and graph that now. The slope is 2 over 1, and the y-intercept is 3. So plot the y-intercept first. So we have the y-intercept at 3 on the y-axis, and then you want to go up 2 over 1, and you can go down 2 and left 1, so you have more points for the boundary line. And now we're going to be creating a solid boundary line because it is including with that line underneath the inequality symbol. So create a solid boundary line, and then we'll talk about the shading. We will be shading below the line because the symbol is less than or equal to. And hopefully remember from chapter 2 that you can always check your shading by using a test point. And the usual test point that we use is the origin 0, 0. If the origin is on the boundary line, then you want to use some other point that is in your shaded region to ensure that you shaded on the right side. Before moving on to graph the second inequality, I would like you to, if you're listening to me right now, please write on the side of your notes, "Hi, Mrs. Allen," so that I know that you're listening to this video and I can give you full credit for that. Thank you so much for doing that. Now let's go ahead and start graphing the second inequality. It is already in slope-intercept form, so we should be good to go to graph it now. So we know that the slope is negative 1/2 and the y-intercept is 1, so I'm going to go ahead and plot the y-intercept at 1, and now we're going to be using the slope negative 1/2, so that means we're going down 1 and right 2. So continue that pattern, and then now start at the y-intercept and go up 1 and to the left 2 until you run out of room. This boundary line is going to be solid as well, but instead of shading below, we're going to be shading above because we have the symbol greater than or equal to. When you shade the half planes, I suggest that you shade in opposite directions and also use different colors if that is available to you. So you can see that the overlap of this system of linear inequalities is located in the top right region. So all of the points that are in that overlap or that double shaded region work for the inequality. So now I'm just going to show you how to check to make sure you shaded in the right area, and we're actually going to follow a very similar process to what we did in the past. To check that we shaded in the right region, we need to pick any point that is in the overlap region, such as the coordinate point 0, 2. In this problem, we're not going to be using the origin because, as you can see, the origin is not in the overlap shaded region. So let's choose 0, 2, and plug it into both inequalities to make sure that it satisfies both. When substituting in the coordinate point for the first inequality, we find out that -2 is greater than or equal to -3, which is a true statement, so it satisfies the first inequality. Now I'm going to be substituting the coordinate point in for the second one. As you can see, when we plugged in the coordinate point 0, 2 for the second inequality, it also worked. We got a true statement 2 is greater than 1. So that means since it satisfies both inequalities, that region that we shaded in the top right corner of the graph is indeed the solution set for the system of inequalities. When modeling a real-world situation with a system of inequalities, we need to determine what kinds of solutions actually make sense for the problem that we're dealing with. Real-world solutions are often whole numbers, so only certain points in the region of overlap will solve the problem. Let's take a look at example 3 and see what the solutions will be. Here's example 3. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? First thing we want to do is identify what variables we should use. Let's say that X is the number of balcony seats sold and Y is the number of orchestra seats sold. For the first inequality, let's take a look at the price per seat and then attach the price with the variable. So the first one, X, is the number of balcony seats, and $20 is the price for a balcony seat. So we're going to say 20X plus 30Y, because each of the orchestra seats costs $30, and they want to raise at least $30,000. So that means we want greater than or equal to $30,000. So that means $30,000 is the least amount of money that they want to raise. And the other inequality that we're going to have is Y is less than or equal to 500, because Y stands for the number of orchestra seats, and they told us that the center only has 500 of those. So we have to have Y is less than or equal to 500. Now what we want to do before graphing is, of course, make sure that both equations, or rather inequalities, are in slope-intercept form. The last one's fine just because there's only one variable and the y is by itself. However, the first one, the y, is not isolated for, so that's what we want to do now. To put the first inequality in slope-intercept form, you want to subtract 20x to both sides and then divide by 30. And when you reduce, you get the inequality y is greater than or equal to -2/3 x plus 1,000. I'm now going to show you how to use your graphing calculator to solve for the solution for this set or system of inequalities. So get your calculator out and turn it on. And now you want to go to Apps, and then hopefully your calculator came with this app. It's called Inequalities. And if you don't have that app yet, you want to pause this video now and go to Google, type that in, and find it and download it to your calculator. So now, assuming that you have this app on your calculator, let's go ahead and figure out how to graph the system of inequalities. So you want to press, after you go to Apps, you want to press Inequalities, press Enter, and enter any key, and it takes you straight to the y equals screen. Typically, you would have to go to the top left corner to press the y equals button. And now you can see that it's highlighting the equal sign, and then we have all the inequality symbols at our leisure right here so we can use them. So now let's go ahead and type in our two linear inequalities that we have in the box right here. So when we want to type in this first one, we want to use the greater than or equal to symbol. So you want to press alpha, which is this green button, and then go to graph, because that is basically using the greater than or equal to symbol. And you can see that the equal sign now changed to a greater than or equal to symbol. And then now you want to type in the fraction. My suggestion is to use parentheses when dealing with a fraction, and make sure you use the minus sign or the negative sign here instead of the subtraction symbol. So -2/3 x plus 1,000 is our first inequality. And now you're going to go to y2 and highlight the equal sign, and now we're going to be using less than or equal to, so go to alpha and less than or equal to. which is pressing zoom after you press alpha, and then you want to type in 500. Before pressing the trace or graph button located in the top right corner of your calculator, you want to make sure that your window will include the solutions. So go to Window, and then now make sure your x-min and y-min are at 0, because we don't need to worry about negative solutions. It's a real world situation. And then for the x-max and y-max, I suggest putting them at around 1,100. So once you have your window match mine, now you can go to Trace, and you'll see the graph of the system of inequalities, and you can see that the overlap is located in this region right here. So that means the solutions that are in that shaded region are the solutions for the system of linear inequalities that we created. You may be wondering, what do the points in the overlap represent? Well, the points represent the combinations of the balcony and orchestra seats that have a total value of at least $30,000. Now let's test a point. So I'm going to choose the coordinate 900, 450. That is the solution of the system because it is in the shaded region, as you can see right here. And now, as usual, when we're testing a point, we want to plug that point in for both of the inequalities to ensure that it works. So let's use the first one. 20 times 900 plus 30 times 450. Does that equal, or is that greater than or equal to 30,000? And when you multiply and add those numbers, you find out that the left side is 31,250, and that it is greater than 30,000. And now for the second inequality, which is just y is less than or equal to 500, we just need the y coordinate of our test point, which is 450. And that is less than 500. So it does work for both inequalities. So that ensures that we have the correct solution set shaded. And because the number of seats must be a whole number, only the points in the overlap that represent whole numbers are solutions of the problem, because you can't sell half of a seat or a portion of a seat. So now we're going to write that now for our conclusion. Up until this point, we have only dealt with systems of inequalities that have been linear. It is possible to have nonlinear inequalities in a system as well, and we can solve these by graphing them, just like we have before. So we're going to be using our skills from the previous chapter, chapter 2, when we learned how to graph a absolute value inequality. So let's move on to this problem. In example 4, we're given the system of inequalities. Y is less than or equal to 3, and y is greater than or equal to the absolute value of x minus 1. So the first inequality is a horizontal line, because it starts with y equals and there's no x involved. So let's graph that. Go to the y-axis and go to positive 3, and then draw a solid horizontal line going through that point. Make sure you put arrows at the end, and we're going to be shading below due to the less than or equal to symbol. For the absolute value inequality, we know that it's also going to be a solid boundary line. Remember, absolute values look like a V or an upside down V. This will be a V opening up because the A, or the leading coefficient, is an invisible positive 1. And hopefully you remember from last chapter that when a number is inside the absolute value, symbols such as x minus 1, we are going to be going to the right one. And that's because the minus sign is part of the original or general formula for absolute value functions. So the vertex is going to be on the x-axis because we're not vertically translating this graph at all. And then since the a is a positive 1, we're just going up 1 over 1 in both directions. Okay, so now you want to connect. And we're going to be shading above because the symbol is greater than or equal to. So you can see the overlap is actually a triangle in this situation. I'm going to highlight it so it's obvious to you. So this region right here contains all of the solutions of the system of inequalities. And the shape of this overlap is different from the other system that we saw today because the overlap is not formed by two half planes, so it is more varied in shape. So this triangular region of the overlap represents the solution set for the given system of inequalities. And as always, you can check your answer by choosing a coordinate point that is in this overlap. I would probably choose the coordinate point 1, 1 to ensure that we shade it in the right region. Now the lesson check is left for you to do. So make sure you write down all 4 problems, show your work, and let me know if you have any questions the next time we meet.